Well, good evening, boys and girls, ladies and gentlemen. Pleasure to be here. It's my first TED Talk, and I hope I do okay. You can grade me, and if I do below a certain average, then I will improve and do better the next time. You had a lot of very good words and advice from Susan and Maria, and now we're going to go into space. I wish that we have a little less light on the stage here because space is very dark, and if there's too much light on the stage, then the pictures will not show the beauty of space. Why we go to space? It's expensive, it's dangerous, and many people wonder why we do it. I'll try to give an answer quick. I mean, this whole talk is going to be about 20 minutes, and space exploration is a huge subject, so I'll have to be sometimes a little quick or cut off some side subjects. Obviously, there are some practical applications of space which are very important. Communication is, of course, a very important one. Navigation, precise navigation, is a huge plus brought by the access to space. The ability to know your position to within a few meters with a GPS and soon with a European Galileo system is an enormous plus for convenience and mainly for safety, whether it's with your car, with your boat, if you go mountain climbing or with airplanes, navigation, of course, it's an enormous plus. And the last point is Earth observation, including weather. It has brought a lot of knowledge about planet Earth and the resources of planet Earth and about weather forecast. And I will not talk too much about these because the theme today is explore. And of course, we go into space because we want to explore. We want to satisfy our curiosity about the object of the universe, about the sun, about the Earth itself, about ourselves. We always try to understand nature and the stars, always. And of course, we use different machines and systems and instruments and telescope over the centuries in order to try to answer our questions about the universe and about the nature of stars, of planets, of the sun. The moon, of course, it's our nearest neighbor, only about 400,000 kilometers away from us. And if you look at the moon with a telescope, that's what you see. It's a relatively small celestial body in the solar system, doesn't have an atmosphere, so when it gets hit by meteorites, it creates these craters. Unlike the Earth, it was protected by the atmosphere. That's what you see when you look at the moon with a telescope. And as you know, space exploration started with the launch of the Sputnik satellite in 1957. A few years later, the first man in space, Yuri Gagarin, in this Cold War climate between the United States and the Soviet Union. And the response of the US was, as you know, the Apollo program, an absolutely magnificent program, very difficult. It was a bold commitment to go to the moon with people in the 60s with this speech of President Kennedy it was in mid-May 1961, a few weeks only after the flight of Gagarin. He said we go to the moon not because it is easy but because it is hard. And the fact that it was so hard had as a consequence to focus the capabilities and talents in the United States, and it was really a very remarkable program. The highlight of all of the human space exploration programs. That's Apollo 11, the first flight in the summer of 1969. Interestingly enough, this is an experiment that came from Switzerland, from Bern, that was supposed to capture to trap the particles of the solar wind. And the Swiss are very proud because this experiment was deployed before the American flag on the surface of the moon. And of course, we owe to our American friends the possibility of doing this very interesting study of the composition of the solar wind. And this is a picture of Buzz Aldrin, who is the second on the moon, picture taken by Neil Armstrong, who was the first one to walk on the moon. absolutely superb program. Of course, the main goal was really political. Officially, it was an objective to demonstrate the capability of the US to do an extremely difficult program. But of course, there were a lot of beneficial outcomes from a technical point of view and scientific point of view. This is the way the Apollo astronauts saw the Earth from the moon. And of course, it changed completely our perception of our place in the universe on a very small, fragile planet, like a spaceship with at the present time a little more than 7 billion crew members and no captain. Now, after the end of the Apollo program, Apollo 17 was in December 1972. The US decided to conceive, build, test, and operate a reusable spacecraft for access to low Earth orbit. When I say low Earth orbit, it means a few hundred kilometers above the Earth's surface. And that's the Space Shuttle. It was another huge challenge because the reusability of the Space Shuttle was technically extremely difficult. You had to have a thermal protection system for the orbiter that had to be used over and over again. Unlike the capsules, like in the Apollo program, coming back to Earth through the atmosphere with a lot of heating, they were used only once, but the shuttle had to be used several times. All in all, it was a successful program. Unfortunately, the shuttle was much more expensive than anticipated, also more dangerous. We had 2 accidents out of 135 shuttle flights between 1981, the first flight, and 2011, so 30 years of operation and 2 accidents. And you had a huge payload bay, about 30 metric tons could be carried to low Earth orbit in this payload bay. 7 crew members in the small cabin there. 3 hydrogen engines burning hydrogen with liquid oxygen and producing water and thrust. These are really green rocket engines in a way, producing water and thrust, about 1.5 ton of water per second and about nearly 1,000 ton of thrust. And 2 solid rocket boosters, not quite as green as the hydrogen engines, that provided some extra thrust for the initial liftoff. Now I have a short video clip that will illustrate the first 2 minutes of ascent of the Space Shuttle until separation of the solid rocket boosters. And we'll start it. Fasten your seatbelt. That's going to be quite a ride. Now the ascent into low Earth orbit only lasted 8.5 minutes. 8.5 minutes, so it was a very short trip because space is so close to us. But the solid rocket boosters were separated after 2 minutes, fell down in the ocean, were recovered for later flights. That's we should hear some noise here. Turn up the volume. It's very noisy at this time. Oh well, we don't have the sound. That's a view from the cabin, and then we have liftoff, ignition of the solid rocket boosters with thrust, which is larger than the weight, and then we go up with quite a lot of noise. Relatively low G value, acceleration at the initial start because we are so massive. We had a roll maneuver shortly after liftoff in order to come into the plane of the orbit. That's a view from the cabin. You see the Atlantic coast here. That's a view from a small camera on the tank, and you see the Atlantic coast here. That's quite a ride, I can tell you. Very, very, very impressive, and a little scary, especially when the solid rocket boosters were attached to us. It's very shaky and scary. Then separation of the boosters, 2 minutes after liftoff, they fall down in the ocean. You see, after 2 minutes, we are about 30 kilometers altitude. The sky is already completely black. The atmosphere is very thin. You see the boosters coming down, and that's the orbiter with the 7 crew members and the payload continuing the trip into low Earth orbit until main engine cutoff, 8.5 minutes after liftoff. Now, quick refresher. I'm sure it's a refresher because I'm sure you know all of this about orbit. Orbit is basically free fall. If you imagine that you're on a mountain, you remove the atmosphere around the Earth because you don't want to have the drag of the atmosphere. This is a thought experiment. You are on a mountain, you have a gun, and if you shoot bullets with a relatively low speed horizontally, it will fall down here on A, a little higher speed, it will come on B, but the Earth is round, it's curved. So you can imagine that for a given speed, the bullet is going to fall down to Earth, but it will never reach the Earth. And that speed is about 8 kilometers per second or 28,000 kilometers an hour. It's pretty high speed. But you have to, I do this in order to illustrate that being on orbit is like being in free fall. It's like being in an elevator when the cable breaks. You're in free fall. It doesn't happen normally, and it normally doesn't end very well if it does happen, but extremely rare. But you don't have weightlessness in a spaceship, whether it's a space shuttle or the International Space Station, because you are far from the Earth. You have weightlessness because you are in free fall, and I think that's a good illustration of that. And here we are, we're on orbit. And it's magnificent. It's really breathtaking, the view that you have. We've opened the payload bay doors. This is the view of the payload bay from the aft windows of the cockpit. Here we are about 400 kilometers above the Earth's surface. It's really, really stunning and beautiful. Now for the ones who like airplanes and cockpits, that's a dream picture. This is pretty much like the cockpit of a modern airliner, like the Airbus 320, 330, or the Boeing 777 modern airliner, but it's in space. And you see here the Earth upside down, the sky is completely black. And that was a remarkable achievement by the US aerospace industry and NASA. Create a vehicle pretty much like an airliner that goes into space and comes back and lands on the runway at the end of the mission. And this is an overflight of this school here, 400 kilometers over Adlisville, which is here, as you know. It's a nice picture that was taken from the International Space Station in the summer of 2005. That was 3 years after the accident of Columbia. By the way, the mission commander was Eileen Collins, a woman. Women are very present in the American space program. And they were doing a so-called pitch maneuver in order for the crew on board the International Space Station to be able to monitor the whole thermal protection system of the shuttle to be sure that it is in good shape to ensure a safe re-entry at the end of the mission. So picture taken from the International Space Station as the shuttle and the ISS were overflying Adlisville. That's a nice picture of the shuttle taken from a little satellite that had been deployed from the payload bay of the shuttle. You can imagine the shuttle flying like an airplane with a 90 degrees angle of attack. Angle of attack doesn't matter because you are outside of the Earth's atmosphere. You could never fly like this with an airplane horizontally with the wings perpendicular to the velocity vector. But you can do this in space, obviously. This was on mission number 7 of the Space Shuttle in 1984. And this was taken from a small satellite deployed from the payload bay. Another time they deployed a human being. This is Bruce McCandless. It's an American astronaut who had, on a spacewalk, went to take a manned maneuvering unit, which was a small personal spacecraft that allowed him to move away from the space shuttle a few hundred meters without being physically linked with the space shuttle. He had no safety tether. And he's moving around the Earth at 28,000 kilometers an hour with his little personal spaceship. This is really great. Anybody wanting to do this? If you have the opportunity one day to do this, you should say yes. Yeah? I recommend very highly. Bruce McCandless. What an adventure. Now, every shuttle mission was relatively short. It was about typically 10 days, between 8 and 15 days, I would say. 15 was a maximum. And of course, we had to work. We had work days of about 12 hours, and we went 8 times around the Earth in these work day 12 hours. Then we had a little free time, then sleep for about 6 to 7 hours, then a little free time at the beginning of the day, then again work day 12 hours. But when we had a little bit free time, of course, we were looking out the window, obviously, but sometimes we're playing with fluids also. This is a way all the fluids, whether it's whiskey, but we didn't have on board, or water, or coffee, or orange juice, this is the shape it takes. And it's obvious that it takes this shape, because in weightlessness, all the directions are equal. There's no up, no down. So the only shape that gives you this property of all directions being the same is the sphere. This is really cool. And if you blow on it, you create waves and it moves. And it was really, I wouldn't say strictly forbidden, but by far not recommended by NASA, because you have electronic system in the cabin, and if you have a big blob of orange juice that come into electronic system, it can be damaging. But we had always towels, so it's okay. This is my commander on my first mission. I did a total 4 missions in the 90s, and on my first mission, Lawrence Shriver, an American colonel of the Air Force, was a commander, and he's eating M&Ms or Smarties that move slowly from his open hand to his mouth. Nice picture. This is preparation of food. These are scrambled eggs prepared by one of my fellow crew members for the crew. We had normally food taken in dehydrated form, and we had to rehydrate with water produced by the fuel cells of the Space Shuttle. About 100 liter water was produced each day by the fuel cells. So we have rehydrated the scrambled eggs and eating them, and it was okay. It had the texture, the color, and the taste of scrambled eggs. Sleeping bag, and again, about per 24-hour slice in the flight plan, we had about 6 to 7 hours of sleep, and we had our sleeping bag that we can install on the ceiling, on the sidewall, on the floor, which is normally not the case because it's no fun. It's better to be on the sidewall or on the ceiling. Yeah? International Space Station, this is a spaceship that is on orbit around the Earth, occupied permanently by 3 up to 6 people, and there are a large number of modules procured by the 16 partner nations. In fact, you have United States, Russia, Canada, and Japan, 12 members of the European Space Agency, including Switzerland, that have gathered their resources and talents and financial means to create this big laboratory in space where experiments are being done, and there's also production of some elements that are being produced in the weightlessness of space. For instance, you can generate very pure crystals because you don't have the convection in the liquid phase before the solidification. Then you see the shuttle attached to the International Space Station. The shuttle was essential for the assembly of the ISS between about the year 2000 and 2011, when it was taken out of service. And this is Expedition 42 on board ISS. In fact, these were all 6 crew members that were on board until a few days ago, when these 3 came down to Earth using the Soyuz Russian capsule landing in Kazakhstan. So right now we only have these 3, including an Italian astronaut from the European Space Agency, Samantha Cristoforetti, and we have a Russian and an American on board. Basically, it's doing experiments, mainly using the microgravity or the absence of convection and the absence of gravity in the spaceship, using for the glove box to do medical experiments or biological experiments. I personally never went to ISS, but I went twice to the Hubble Space Telescope, which you see here. Also cooperation between the European nations and NASA. It's basically a telescope in an ideal position because it's outside of the Earth atmosphere. So it gives us a very, very clear view of a faraway object or near object like in the solar system. And we had the capability to go and visit it every 3 or 4 years to do either repairs if needed or improvements. Typically, you have scientific instrument in the instrument part of the telescope, and we had the capability of changing the instrument to keep the facility as a modern instrument. You probably know that, but this is the way these reflecting telescopes work. This is Hubble instrument part, and this is the optical part, and you have the radiation, basically parallel radiation, because the objects are so far, coming from the left, hitting the primary mirror, chained to a converging beam, to a secondary mirror, second reflection. Then the focal point is here, and the image is formed here behind the primary mirror. We had a problem initially with the telescope, which didn't have a good sight, because we had the primary mirror didn't have exactly the right shape, so we had to install an optical corrector, and I was part of that mission, which was in 1993. Hubble SM is for servicing mission 1, December 93. I was there with 6 of my fellow crew members. We are now over Australia, 600 kilometers, doing a spacewalk. You have 2 crew members here doing the spacewalk. We just exchanged the solar arrays. We had to install an optical corrector, increase the memory of the main computer, change the solar arrays, exchange gyroscopes for the attitude control. So various servicing acts had to be performed. This is a great picture, 600 kilometers over Australia. We trained a few years later for another servicing mission. I was again one of the crew members, this time one of the spacewalkers. And we trained for spacewalks in the water because you can simulate the absence of gravity in the water. If you are properly adjusted in terms of the weight in all parts of your body, you are really like in weightlessness. This is a very precise model of Hubble in the water, including the doors that we could open. All the scientific instruments inside were exactly like the reality. Excellent training in the water for preparing another servicing of Hubble. And here we are, Hubble servicing mission 3A, 6 years after the first one. That was December 99. And I'm here at the end of the robot arm installing a new fine guidance sensor. That's the old one that was broken. We had put it temporarily on the side of the payload bay, then we'll put it back in a thermostabilized container in the payload bay where the new one was, and I took it and I'm installing it in the computer, aided by Mike Fowle, my fellow crew member on this spacewalk number 2 of this mission. He's doing the ascent of the north face of Hubble in a way. And he has a safety tether. You don't see it, but he has a safety tether. Unlike Bruce McCandless, where it's no safety tether, we always had safety tethers around Hubble. Here I am. That's the second spacewalk. Still, we are exchanging with Mike Fowle the main computer of Hubble, so like brain surgery. Spacewalking is really cool, but you need to be careful. You need to really be very rigorous and systematic the way you do things. Many people think that spacewalking is just coming out of the airlock and having a lot of fun seeing the stars and the Earth, but it's work, work, work. And sometimes you have great views, but most of the time you are just focusing on the work you're doing. I want to show a few pictures taken by Hubble, but I have to go rapidly. There's about 1 or 2 pictures every week sent from Hubble, which are absolutely stunning, mainly about star formation in our galaxy or a faraway object like galaxies. This is the Horsehead Nebula seen by Hubble. It's a cloud of gas and dust in the Orion constellation. A beautiful picture of a galaxy, which is a gathering of about 100 billion stars, pretty much like our galaxy. The Sun is one of the about 100 billion stars in our galaxy and more in the periphery of the galaxy. And this is the most stunning picture taken by Hubble. Maybe not the most impressive from a visual point of view, but it means a lot. The telescope was left pointed for 10 days in the same region of the sky. It's a very small window of 2 arc minutes by 2 arc minutes, and it gathered the photons or the grains of light for 10 days. And it in a region of the sky where there was basically nothing seen from the Earth, even with telescopes. And it revealed the presence of hundreds and hundreds of galaxies. And it showed us the extreme high density of galaxies in the universe. And of course, it allowed us to see very, very far. The faintest galaxies in this picture, the Hubble Ultra Deep Field, are about 10 billion light years away. We see them as they were 10 billion years in the past, not million, but billion, 10 to the 9. Really amazing result. Quick look at the Earth. Beautiful views again. Sometimes we played with fluids, I mentioned, when we had free time. Most of the time we looked at the Earth through the window. This is the Himalaya, all of Himalaya from Pakistan all the way to China. This is northern India with the Brahmaputra River. Tibet. Everest is about here. Nepal, Bhutan. Beautiful. And a good way to learn geography, I can tell you. Where are we here? You have 10 seconds to answer. 9, 8, 7, 6, 5, 4, 3, 2. What did you say? This is northern Italy. This is Switzerland. This is Milano and Torino, Genoa here. This is Switzerland, and we are here. This is Lake Zurich. The lights of Zurich. Atlasville is here. These are the lights of Atlasville. This is Lake Geneva, and this is during the winter, so there's some fog in some areas. Even in the Rhone Valley, there's some fog. But you see how bright northern Italy is, and Switzerland doesn't shed a lot of light because you don't have huge cities like you have in Italy or the US or other parts of the world. But it's quite a nice picture of this part of the world. The goal of NASA is to send people in a couple of decades to faraway destination, to Mars. Of course, we had the moon in the 60s, then back to low Earth orbit to do a lot of work, and very valuable work with ISS and with Hubble. But the idea is to go back to another faraway destination, and this time will be Mars. Mars is studied in great detail with a lot of space probe like Mars Express of ESA. You see a detailed picture of the surface of Mars taken by Mars Express. Some day we'll send people there, probably in the 20s or 30s of this century, probably as an international mission, not NASA only, but with Europeans, Canadians, Japanese, maybe Chinese also. It's going to be international cooperation to go to Mars on a human mission. We explore space, but we also need to take care of planet Earth because most of us will stay here. That's a fact. And in fact, many space missions have as an objective to monitor the Earth, and again, either to look at the weather pattern and do a forecast, or study the resources of the Earth for a better utilization of the resources of our planet in the future. Thank you for your attention. Yeah.